Good morning, everyone. Welcome to my talk, Infrastructure as Code with Terraform. Anybody using Terraform right now? Oh, okay, good amount of people. Anybody familiar with Infrastructure as Code? Besides the people who raised their hand. Excellent. So to some of you, this is new. This is not a very super in-depth talk about Terraform. I'll give you an overview because it'll take a lot longer to go through all the nooks and crannies of Terraform. So I'll give you a pretty good overview of it, what it's capable of, and how you use it. So who am I? Okay, that's not what it is. There it is. Yeah, so Greenlee. I am a DevOps engineer for Insight. Insight, I have talking points here. We're a digital innovation company. We do cloud enablement, data and AI, DevOps, digital strategy, intelligent applications, IoT and smart edge, transformation services. So we pretty much run the gamut of IT solutions. We are hiring for DevOps engineers, so if anyone is interested, insight.com. I'm also the organizer and founder of the Blacks in Technology organization. We're an organization focused on increasing the participation and representation of Black women and men in tech. Born and raised in Cincinnati, certified Jedi Knight. I trained at Dagobah System 19. All right, Linux enthusiast, comic book enthusiast as well, husband and father. So our agenda for today is, what is IAC, or Infrastructure as Code? What are some of the benefits? What is Terraform? Why do we need Terraform? How do we use Terraform? We'll go through some of the Terraform objects, such as providers, resources, variables, all that good stuff. And then how do I get started? I was going to do a demo, but the laptop that had the demo stuff went kaput, so I'm not going to demo today. All right. What is Infrastructure as Code? Basically, it's the ability to describe and define your infrastructure and application in source code, right? In Terraform, you use what's called Terraform manifest. You declare what you want, the resources that you want, how they connect, and then it pretty much goes out and to any of the cloud providers or any provider that you specify, and it builds the resources that you declare. And there's other tools that do this as well. AWS has CloudFormation. Azure has ARM templates. Google has Wizardry and Magic. So there's a few of them out there that do this type of thing. Some of the benefits of Infrastructure as Code. Now, since your infrastructure is declared and described in software, right, you can pretty much use software methodologies, tools, and practices in order to kind of govern how you use it. So code reviews, automated testing, linting, all those now apply because your infrastructure is now described in code. There's other benefits as well. Automation, right? Now that your infrastructure is described in code, now you can put that code in a pipeline and you can automate the building of your infrastructure. Version control, right? Which version do you like, right? Now that you're using your infrastructure is described in code, now you can version control it. Now you can commit it to a Git repo, and you can tag it. And so now you can add features. You can work on it the same way you would do with software, collaboratively with your team. They can check out branches, or create branches, they can commit code, back up to master, and now you can choose. Now it gives you the ability to say, hey, I'm working on this feature, I'm going to commit this, now I'm going to tag it, and now we're running with feature 1.1. And if something happens, your automated testing didn't fine, then you can roll it back, right? Now you can go back to 1.0. And so you could either use the Christian Bale version, or you can use Ben Affleck version, or you can use Adam West version. So that's a really good and powerful way of dealing with your infrastructure as codes. Now that it's in software, you can version control. Rollbacks, right? Now you can, as I described earlier, you can go backwards. Now, if you deploy something in master and you deploy that out to production, something breaks that you didn't anticipate, right? Now you can roll that back. All it takes is a change in a tag in your pipeline of which version you want to use, and now it's easily rolled back from Thor 1.0 to Thor 1.0. Documentation. Did I skip one? I don't think so. Let's see. No, I didn't. Documentation, right? Your software is, or your infrastructure is now in code, so that automatically gives you the ability, or gives you documentation. Everything is described in your infrastructure as code manifest. So if, for instance, you bring on a new DevOps engineer and they want to know how things are connected, what resources are out there in your cloud, now all you have to do is show them the source code, right? And that gives you automatic documentation. Also, there's correlation, there's visibility, there's traceability, this to be gained by infrastructure as code. All right, so we're going to move into what is Terraform. We already talked about infrastructure as code, so that's what it is. It's a management tool that uses a declarative language to build infrastructure. It's written in Go. You can check it out on terraform.io. And you pretty much write your infrastructure. You plan it. There's a command called Terraform plan, and it allows you to see the changes you're going to make before you actually make them. And then there's a Terraform apply, and that allows you to create that infrastructure that you just specified or just declared. And the cool thing about this is it's reproducible. You do it once, and it may take some time for you to actually describe all your infrastructure in code, but you do it once, and now you have that template for various different environments. So you might have one for prod. You can use that same template for dev, and you can use that same template for test or whatever environments that you have. And Terraform will allow you to be able to kind of switch in and out variables for different environments, and I'll show you that a little bit here soon. Because of course, like if you have your prod environment, you might not want the same, let's just say, instance size for dev or for testing. All right, imperative versus declarative, right? Imperative is the how. If you want to make a chocolate cake, you list all the steps in order. You buy the cake mix, you open the cake mix box, blah, 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 blah. And you bake it 350, and hopefully you have a cake at the end. Declarative is, I need a chocolate cake big enough to feed 20 people. That's what Terraform gives you. It has that power where you can just declare what you want, declare the resources, and then you actually go out, hit Terraform plan, Terraform apply, and it goes out to whatever provider you specify, and it builds this infrastructure. So, why do we need Terraform? Infrastructure is hard, right? All those dependencies, all those connections, stuff is hard. And you want to, and sometimes you don't want to, you want to concentrate on like what the business outcome is instead of having to muck around with a bunch of infrastructure, right? And this is not the face that you want to have while you're looking at your infrastructure. You don't want to look at your infrastructure and groan every morning. You want to know that it's in a stable state. You want to know that exactly what you specified in your code is out there in the cloud. And so Terraform gives you that ability. Abstraction, right? Terraform is a layer above, let's just say, the APIs. It exactly does that. It communicates with the cloud providers or whoever's API, and it builds infrastructure that way. And so it uses HCL, which is Hashicorp's configuration language, and it actually reaches out to these APIs, makes these API calls, and it builds out your infrastructure. And a big word of today, Big word alert, big word alert, big word. Anyhow. It is idempotent. Yes, you're smart. I had to look up how to pronounce this word a couple of times. So what that means is you run it once and you get the same results, right? You can run Terraform because of its declarative nature. You run it once and you declare, for instance, I want one VM out in AWS. No matter how many times you run Terraform, you're only going to get that one instance, unless, of course, you say I want 2 instances. But it's never going to have more than what you specify in your code. Cloud agnostic, sort of. Sorry. It's sort of cloud agnostic. You can't just write Terraform code for AWS and expect that same code to work in Google. Or in Azure. So everything, the syntax, how you declare resources, how you declare variables. Terraform operates on any file with the extension of .tf. Come on, man. What's going on? All right. Oh. It's back. Oh, it's gone. It's back. Let's see. All right. What in the heck? PSAV? Got some words for you. All right. Let's try to continue with this before it gets out of whack. So you write your code, and you give it a .tf extension. You also pass in variables to that code because you want it to be reusable, right? It's Terraform's way of dry, which is do not repeat yourself. So you use variables. And of course, that's just good coding practices as well, to use variables instead of hard coding stuff, right? Terraform then goes out to the cloud provider, communicates with this API, does all this stuff magically behind the scene, and it creates your resources. Creates everything from your VPC, Amazon EC2 instances, load balancers, all that stuff. And once it's applied and it's in a stable state, it actually writes out what's in your infrastructure to a Terraform or TF state or a state file, right? And that state file is what's mapping all of your resources to what you declare in your Terraform manifest. And so if you expand on this idea, right, now you can pass in different variables for different environments. And this is not exactly how, but gives you a general overview of how you would do this. We do this in Insight, we do this in pipelines. So we have a pipeline for dev, we have a pipeline for test, we have a pipeline for staging, and a pipeline for prod. And depending upon which pipeline is ran, it will exchange or pass in variables to that Terraform code. So we declare a variable. So for instance, our variable is called cluster ID. We prepend that to the resources when we name them. And when it goes to the pipeline, it actually says, oh, okay, based on this cluster ID, and you're running this in dev, now I'm going to prepend dev to each one of your resources. And then because of that, you get a Terraform state for each one of your environments, which is cool because now that's separated And if at any given time, and we back up, our state is remote. If you do it at home, if you install Terraform, download the binary on your laptop, and you run it, you'll have a local copy of the TF state, right? But having a local copy is not good when you're working in a group. And so we use what's called a remote state. And that allows us to be able to pull down a remote state, work on it, and then those changes are then made. So every change that gets made, the group knows about it, right? And so you get a state file for each one of the environments. So how do we use it? It installs as a single binary, which is cool, because then you can run it on a variety of operating systems. And the usage of it, hope people can see that in the back. Terraform init, right? That's probably the first command that you're going to run, and it initializes your Terraform directory, pulls in all the plugins for the provider, and we'll talk a little bit about the provider here in a second. And it pulls in modules, and we'll talk about what modules here are here in a second as well. So you initialize your Terraform directory, you write your code, and then you do a Terraform format, which kind of beautifies the code. It makes things a little more readable in a canonical format style. You do a Terraform validate, which checks the syntax of your Terraform code. You do a plan, and that gives you a preview of what changes will be made. You do an apply, and that applies the changes. And then that is what is going to create your state file after the apply is done, right? Then, if you want to blow away all your changes, you just do a Terraform destroy, and it'll go out and it'll destroy all those changes. Terraform show will show you all the resources from your state file. So if you are onboarding somebody new, or you just want to see what's in your environment, right? You can do a Terraform show, and it'll give you a JSON formatted representation of what's out there in your environment. So providers. So Terraform providers are the way that Terraform interacts with the different, and there's a ton of them. This is just some of them, but there's a bunch more out there. Terraform, I mean, they're adding providers all the time. And so this is what tells Terraform which API to use. It pulls it down and it says, okay, all the modules and everything that's for this provider, right? This is how we're going to connect with that cloud provider and build our infrastructure. So this is kind of how, and after each one of these, I'll just kind of show you a code example. This is how you declare your provider. It's pretty simple, right? You give it the name of the provider. You specify which region you want to build your infrastructure in. And then also you could pass in authorization keys, right? You don't want to do that directly in code, of course, right? You don't want to get a $40,000 bill like I did one time by putting your auth keys in your code, even if you're playing around, right? Because that can, I actually did that one time and forgot to take it out and committed my code to GitHub and got a bill from AWS for $43,000 because somebody took my keys and they had tons of instances running in every single region in AWS. Luckily, they wiped it out and I didn't have to file bankruptcy, so that was cool. My kids had Christmas. So I was able to stay in the house. So yeah, that's how you specify a provider. Resources are the bread and butter of Terraform. These are the infrastructure components that you want to manage. So everything from virtual machines to load balancers, anything in any of these providers, shouldn't say anything, most things in these providers are in Terraform. And if they're not, you can reach out to Terraform and see, what's on the upcoming list. they're doing upgrades all the time, so they're putting new versions out, Terraform out. So sometimes it's just all about just kind of checking back and seeing if that specific resource is now being offered. So this is an example of some code. Hope that. So this is basically saying I'm going to declare a resource for an AWS instance. I'm going to give it the name web, and in your Terraform code, this has to be unique. This is how Terraform maps it to the actual resource in the state file, right? So when you build out an AWS instance, it gets an instance ID. That is what's in the state file. That is what maps it to what you declare here in the code. And so then you give it an AMI, or so you have AMI, you have instance types. These are resource attributes, right? And so with each one of the resources that you specify, there are going to be attributes that tells you like what type of resource you want to build, or what attributes you want your resource to have, I should say. So I'm sorry. Amazon Machine Image. So it's just an image, right? And this one here, you have to specify an ID, AMI ID, and so this piece of code here is actually saying data is a read-only representation of data that gets pulled from AWS, right, or whatever cloud provider, and it's saying I want the ID, right, of the AWS AMI Ubuntu image, right, and then this is called interpolation, and this is how Terraform does interpolation, the $, and then the brackets. And then so it goes out to AWS and it grabs the ID, interpolates it here, and gives you that AMI ID there. The instance type, right? This is just the size of the actual AWS instance. And in practice, you'll substitute this stuff out with variables instead. Because like I said, you might want a different instance type depending on your environment. This might be fine for development, but it's not going to be fine for production. You don't want a T2 micro running in production, right? And then you can give it tags as well. And here, pretty much the same. This is specifying an AWS ELB, which is an elastic load balancer. You give it a name because in AWS, your resource will actually have a name associated with it. You give it the availability zones you want the ELB to be in. Then you specify the AWS instances that you want to have attached to that load balancer, right? So this is doing some interpolation here. It's getting, and this is cool. This actually shows you. So this is how Terraform will grab the ID of this instance that you just created. So you can see here, this interpolation value here, it says AWS instance, which is here, the name, web, which is here, the ID. It's basically saying, give me the ID. And this also creates what's called an implicit dependency, right? So Terraform knows in which order to create resources. It does that using the dependency graph that it does behind the scenes. But when you specify, say for instance here, an instance or a resource that depends on another resource, it'll actually create this resource before it creates this resource. It's that implicit. You can do this explicitly as well. You can do a depends on. If those things aren't linked in some way, you can do a depends on, and it'll actually explicitly link that to the resource and create that resource beforehand. Variables. All right, this is Terraform's way of dealing with values that might change from environment to environment, or just keeping your code as dry as possible, right? So variables are declared either in a few ways. You can specify the variables directly in your the Terraform code. You can use environment variables, which I would not recommend. Sometimes I shouldn't say that. You can use your environment variables as environment variables in certain instances. We do it in our pipeline. So we actually pass pipeline variables into the Terraform container that builds our Terraform code. And when they get passed into the container, they actually become environment variables. And so you prepend all your variable names with tf underscore var underscore, right? And then you give it the variable name, which is some variable, and then you can give us, this is just a way you can do it right at the command line, the export. There are input variables. These are variables that you pass into your Terraform code, and I'll show you that here. Output variables are variables that you get out of the modules that you build in Terraform, right? And I'll talk about modules here in a second and their use. And then the data structures for the variables. So Terraform has strings, it has data structures, like most programming languages, if not all. Strings, arrays, maps. So you can operate on those specific data structures. So here's an example of some code, some variable code. This is declaring a variable called image ID. You're giving it the type, which is a string, and then you're giving it a default value. Now these can be overwritten, right? Your input values in Terraform are usually what you would go as defaults, and then in your Terraform code itself, if you wanted to overwrite those, you can. Gives you some flexibility on, like I said, specific environments that you want different variables or different resource values for different things. So you give it a default, AMI-ABC123, and then you just declare that, you stick that variable in your resource. So before, where we had the actual image ID, now we can just replace that with a variable. Terraform has conditionals. So you can do if statements, you can do if else statements, you can do some Boolean operations as well, right? So here's an example of using count, which count actually, if you want to create more than one resource, you can use the count attribute. So here, what's going on is you declare a resource, AWS instance, you call it VPN. And then what this is saying is, this is the condition, the var dot something, and this is, if that variable exists, then this is a true value and this is a false value. So you can use this to do all types of things, but mostly, for what we use it for is we usually use it for something like this, for count, to create a specific resource. So you say, if this variable exists, then give me one instance of this. If not, then don't create this instance at all. And there's different ways to use conditionals, and this is just one of the ways that you can use it. Terraform does do iteration as well. I think Terraform, what is it, 12 or .12 or something? I can't think of the version, but they now have for loops in Terraform. Before, in order to do, to cycle through like a list, you kind of had to use count. You had to take the length of that list, right? And then you had to do this count.index in order to kind of iterate through that list. And so this would, if you had for instance, a list of usernames, I would declare it as a variable, pass in the names of the users, right? Declare it as a list, and then this would go and it would say var.username 0, right? And that's the first item in the list, and it'll iterate through that. But now you don't have to do it like this. Now they have for loops. It makes it much easier to iterate through list. Modules. Modules are Terraform's way of being able to reuse the code. Of course, you can, anything that is in the Terraform directory is considered a module, right? So, but people will create modules specifically so that you don't have to keep creating the same thing. It's similar to kind of like functions, right? You write your code once, you want to use that in different instances, and so all you do is you kind of call that module, and then you can pass in variables to that module, right? So that you can get the specified resource that you want. So it's just a collection of resources, conforms to dry, don't repeat yourself methodology. And I'll give you an example of how that is used. That might be kind of small. Let me see if I can increase that size. I'm sorry, what was that? Command plus? Thank you. No, it's not. What the hell? What type of... Right.
Yeah, command 0, and then put the other program in focus and try to get.
All right, let's see. This is not working. All right, what the? All right, let's go back to command 0. Damn it, come on. I'm not sure this is going to allow me to do it. Let's see. No, it's not. Sorry. Yeah, I was trying to. Yeah, sorry. So anyhow, you pretty much, what the hell? Get it right. You declare your resources in a manifest file, .tf file, right? Here we're declaring a SQL server and a SQL database. That's what this code over here is doing. You're giving it the name, you're giving it variables as opposed to hard coding anything. So you have a piece of code here that's going to create a SQL server, a piece of code here that's going to actually create the database inside that SQL server. And then this code here is where you instantiate the module, right? You give it a source. Here you can have your modules remote, you can have them local. If it's local, then it's relative to the file that the .tf file that you're working on. If it's remote, you can pass in a get URL. And then here you can actually specify the version. So you can build, and that's the cool thing too about infrastructure as code. Now you can version control these modules that you build. So you build a module, you add a feature, right? You tag that as one dot whatever, and then you commit that, right? And then maybe you add a new feature, but you might not want that feature, and you might not want that specific feature in whatever resource that you're building based on that module, right? So then you just give it reference 1.7, which is the tag. And then you just pass in, so here you can see here we're declaring variables here, and then here we're giving those variables values directly inside in the module block, right? So you can have defaults for these, but then in the module that you instantiate, you can actually override those variable defaults with your own values. And it gives you the ability, so like I said, reuse this code in a number of different environments and different ways. So Terraform actually has functions. You can do string manipulation, there are numeric functions, collection functions, date and time, and just here's some examples of each one. I kind of have, and this is directly on the command line, so you can do a Terraform just on the command line, type Terraform, and it'll drop you into this kind of like this shell. But then you can also use these inside your Terraform code as well. This is just giving you quick examples. So you can do things like max or joins. You can do a timestamp, which It's useful if you're, doing things that need a timestamp, prepended or appended to it, right? CIDR host, which is so you can do networking stuff as well. Concatenation. This is just giving you an example how you have two lists, A and then a space, A and then B and C, and then you concatenate those, you get a new list. So state. State is the big one. State is, it stores your resources, your configurations that you declare. So it stores a state of your managed infrastructure, all the configuration. And it's just used to map your resources to your actual Terraform code. It keeps track of some metadata, and it's stored locally by default in a terraform.tf state file, right? And you can actually open that file up. It's a JSON representation of your code or all your resources out in the cloud. And that's what it uses to create plans, make changes to your infrastructure. I have some recommendations at the end, but I always recommend using remote state. Unless you're just playing around, you're trying to learn Terraform, then local state is fine, but when you're working in a collaborative group, definitely use remote state. So we talked about, we've been talking about state, and I think it's... So this might be the current state. So when we talk about state and we talk about what we want our state to be, our current state of our environment might look like this, right? Because Terraform is a desired state configuration tool, right? You declare what you want, what you desire your infrastructure to look like, and that's what it does. So no matter how many times you run it, we talked about it being idempotent, right? It's always going to give you that state. So even if, for instance, say you have Terraform go out and build a VMware, or not a VMware, but a virtual machine instance, and it's a T2 micro, and then you go in there and you say, oh, manually I'm going to change this to a larger instance size. Once Terraform runs again, it's going to say, hey, it's going to refresh its state and look at that resource and say, oh, hold on for a second. This resource with this ID maps to this resource in our configuration. It's not the same. I need to change that because what you declare, what your desired state is this, and it's not like this. So I'm going to go in and it'll update it and it'll change that image back to a T2 instance to a T2 micro. So that's the desired state, right? At least that's what the empire wants. So how do I get started with Terraform? Understand the resources of the provider. It makes it much easier to build stuff with Terraform. Terraform has great documentation though. So if you don't know, like I started working at a new company at the beginning of last year, and they use Azure, and I had no idea on how that. I was all AWS before that. So I had to switch to Azure, but their documentation is, like I said, once you build stuff for one cloud provider, it's all about what resources are available for that specific cloud provider, and the syntax and everything like that is the same. So once you learn, but understanding the resources and how they connect is pretty important. But Terraform helps you out with that with their documentation. Get a free tier account. Most of these cloud providers, and Terraform doesn't operate on just cloud providers. They operate on SaaS providers. They can operate on physical hardware as well, VMware resources as well. But get a free tier account if you can, and just play around with it. And once you're done, just destroy it. Right? It may cost you a couple of dollars, probably not even that. But it's easy. Hopefully not $43,000. Don't commit your secrets to GitHub. So download the binary, kind of read through the docs, and you just use it, right? Terraform has great documentation on getting started with Terraform. So some of the recommendations that I have: use a Terraform plan output, right? So that's the Terraform plan output. The output is a flag for Terraform plan. And what it does is it allows you to incrementally apply changes to your environment. So say, for instance, you make a bunch of changes and you commit those changes, right? Instead of Terraform taking all of the changes as a whole in one plan file and committing those, which then you have to look through a bunch of different changes to see what's going to be updated. You can do a Terraform plan output, and it'll only take the changes that, say, for instance, you made, and then you can operate. You can use Terraform apply to only operate on that output file, and then so now you're doing this in an incremental fashion as opposed to everyone committing their changes and then having one huge plan file and then output file and operating on that one. Then you've got tons of changes going on. It's just hard to keep track. It's more prone to missing things that may blow up stuff, because you can blow up a lot of stuff in Terraform. Use remote state. I think I talked about that. But back up your state file, because that is your source of truth. Your state file is, and if that goes away, now you can rebuild it. There's a operation called Terraform import that you can take existing resources and you can import those into Terraform. But if you don't have that state file, I mean, there goes your environment. So you want to back that state file up. At Insight, we use Azure storage or storage containers or whatever they call our stuff, and we store our state file in blobs inside the storage containers, and then we back those up regularly. Review the plans, right? It's very easy to get a plan where a lot of changes have been made, and maybe one will impact, because when you're working in a collaborative environment and you're working like inside of different branches, sometimes somebody's change can undo your change. So it's good to kind of have two sets of eyes on your review plans. In our pipeline, there's always a step that allows us to review the plan before we actually apply it. So our pipeline is automated. It builds the Terraform code. It does the plan, and it gives us an output of what that plan is going to look like, and then we can approve it. And once it's approved, it goes through and does the apply. Use secret management. This is huge. I don't know how many times we've walked into a client site and they're storing all their passwords and connection strings and all that stuff directly in the code or directly in Terraform. That is a no-no. Yeah, you're shaking your head. There's well-reputable companies that still do that type stuff. We use secret management. We use Key Vault, Azure's Key Vault, which pretty much just does a kind of replace. In Terraform, you'll say like, hey, I want to create this secret. And you'll say, I want to store that in Key Vault. And then you reference that inside, I don't think I put an example, would have been cool. And then you reference that in the Terraform that you're building. So you say, Azure Key Vault dot whatever the name of the Key Vault that you gave it, and it is basically telling it to go out to the Key Vault and pull that in. We do that at build time. We don't do that any other time. So at build time, it goes out, pulls that in, replaces that, and you never see it, right? You have no idea what that secret is, of course, unless you go into Azure Key Vault and look, but it's just a good way to not get owned, right? And then plan your structure. I mean, you can go willy-nilly with it. Of course, it's better to just kind of plan out, your different environments, how you want Terraform to be structured, because you can do it either per environment, you can do it per application, right? And what I mean is you can build out your Terraform. So like your Terraform directories, for instance, you can have like a dev, you can have a prod, and you can do a Terraform plan and apply on that specific directory, or you can do it by service, like whatever service that you're rolling out, you can do it like that. And I think that's the way we do it in Insight. Is we have like our core, which builds the core infrastructure. So it goes out and it builds all of our networking, it builds our Kubernetes clusters, it builds like a lot of the core services that we use, and then we have Terraform that actually operates and goes out and deploys our applications, right? So it's just good to kind of plan that out and how you want it to look, because once you get so far in, it's not impossible, but it's more difficult to go back and try to restructure things. All right, so resources, terraform.io, of course, that's the website. The Terraform book, which is really good, by James Turnbull. Terraform Up and Running, it's really good. And then you can reach out to me at greg.greenlee@insight.com or my Twitter handle, which is bit_greg_greenlee. And that's it. Any questions? Yes. I don't know. I'm just kidding. Go ahead. Yes. Yes. Right. You're right. Right. And so what he was saying is that using tagging is really, really important, because then you can tag your resources based on the environment, and then you can get a report on what's running in what specific environment, and you can tell like how much you're spending per environment. So we use it for that as well as other things. So good point. Thank you. Yes, sir.
When you were talking about your different environments, do you have to have different config files for each one of those three environments, or can you like do some if logic with them?
You can, yes. You can do both. So what you can do if logic. I wouldn't recommend having different, because you want the purpose of it is to be able to write it once and reuse it in different environments. So what we do is we just pass different variables into Terraform. So based on the environment in our pipeline, so we write it once. Say for instance, like the SQL thing, right? You might want a different SQL instance size, right? So in the pipeline, so that variable might be environment, like var.environment and based on that in your pipeline, you can say if it's this, then pass in this specific value. If it's that, then so I would recommend just writing it once and then passing in whatever variables you need based on your environment. Yes, sir.
How do you manage like state across different modules or state across, because you described like building up your infrastructure, network infrastructure, like core file or whatever.
Okay.
And then you build your application on top of that core infrastructure.
Right.
Do the state files have awareness of each other? I mean, if you change something in the core and that your application isn't aware of?
No, you can. Right, and you can read in values from the state file inside of Terraform. I think you use a data structure or data resource to do it, and it basically you can you can reference whatever is in that other state file in order to do it. But what was the first part of the question? I'm sorry. That was it. Yeah. So they don't have direct awareness of each other. You kind of have to reference it yourself. Yeah. So we have that in our environment where so we're the core infrastructure team. So we build out all the core infrastructure, and there may be an applications team. They may be using Terraform, and there may be values and that they use. That we need to utilize in our infrastructure for whatever reason. And so we just kind of reference that state file in our Terraform, and we can pull in values that way. So, any other questions? Excellent. Thank you. Enjoy the rest of OLF. Appreciate it.